Substitution for a second day in class today, with our focus being on the isolation factor of solving systems. So let's first just take a step and look at solving a system by substitution without anything extra. So the first thing I do is I take my equation, and any way that it's written, I make sure that it's written side by side, so I have these two columns I can kind of work with. Once I have my two columns, I'm going to check both equations, and I'm going to make sure that at least one of them, not a zero, is equal or has a similar setup as this, where I have a y by itself on the left and x by itself on the left in either case. The one on the right, I don't have either of these. Y is not by itself, x is not by itself. Luckily, I have a y equals over here. Because y is equal, I can take all of the stuff that my y is actually equal to. I'm just going to get rid of this because I don't need it. It's just taking up space. And I'm going to replace the y in my other equation with everything that I have circled. So the organization piece of this ends up looking like this. The 3x, the plus, the 4, the equals, the 4, all are there. The only thing that I'm doing is, this is where that y used to live. I'm going to take the y out of the problem and replace it with the information that I have circled over here. Y and x minus 6 are considered to be the same in this problem. We're then able to distribute the 4. And now we're going to solve our equation. So I'm going to put my like terms together and get 7x minus 24 equals 4. I can add 24 to both sides. 7x equals 28. I'm out of room, so I'm just going to scroll. Divide by 7, and x equals 4. Even after all that work, that's only half of the answer. So we know that x is 4, but now we're going to go back and figure out what y is. And we're going to use our other column, the other side of our page, with our newfound answer of 4. So if x is 4, that means I can plug a 4 in right there and solve. 4 minus 6, y is negative 2. The skill that we practiced today in class was, what if one of our equations doesn't say x or y equals at the start? For instance, this problem. I'm going to take 2x plus 3y equals 5. I have the x minus 3y equals 7. I don't have an x equals or a y equals in either one of these problems. That doesn't say y equals, that doesn't say x equals. Nope, 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 nope. But what I do notice, and the thing that I want you guys to also be on the lookout for all these problems, is that this x right here is almost an x equals. The only thing that's stopping me from being x equals is this pesky 3y right here. So if I were to add 3y to both sides, I get x equals 3y and a positive 7, so plus 7. And now I do have an x equals. So we want to find the letter that's mostly by itself, and we're going to make it fully by itself. We're still working with this two-column kind of system here. So I've got this one. X is equal to all of this, so I'm going to make sure that I plug in for x. So I get 2. That's where x is going to go. 3y equals 5. 3y plus 7. distribute, and now we're going to solve. Combine my like terms, 3 and 6 give us 9y. I can subtract 14 from both sides. Oops. 14, that gives me 9y equals negative 9. I divide by 9, and y is negative 1. That's still just half of an answer. Negative 1. We're going to take what we just found, jump back to our first problem, and where we have y, we're going to replace it with that negative 1. 3 times negative 1 is negative 3. Negative 3 plus 7, and x is 4. So I want to quickly go through. We're going to do one more full problem, but I kind of want to look at which letter would be the best for us to get by itself. So this next one, best choice, this x right here, because it doesn't have a number attached to it. And this one, you wouldn't have to get anything by itself because there's already an x equals. This one, there's only one bad choice. This would be a perfect choice. This one would be a perfect choice. This one would be a good choice. Anything but this 3y. Notice that he's just a little bit more crowded than the rest of them. This x on this problem would be a good choice. It doesn't have a number. This y would be a good choice because it doesn't have a number. And then when you get to a problem like this where you're like, oh man, I don't know, we're going to learn a completely new technique to get rid of this one. You won't see any of these on your homework either. So the one I want to look at is actually this one right here. So I'm going to write down my equation side by side. 7x minus 9y equals 17. And I have negative x plus 4y equals 3. We already decided earlier that this x is the best one to isolate. In order for this x to be by itself, I have to move the 4y's away from it. I'm left with negative x is equal to a negative 4y and a positive 3. And we're still not quite there. I need it to be a regular x. Right now it's a negative. So we're going to divide by a negative. But when we divide by this negative, everybody has to get divided along with him. If this x is going to switch its sign, everybody's going to switch their sign. And just like that, we have our x equals. So let's go back to the top and kind of look at it step by step again. I moved the 4y by, it was adding, so I subtracted. There's this negative 1 hanging around. I don't want that negative 1, so I divide by negative 1. And now we've got our positive x. We take all of this, plug it in over here, so we have 7, empty space, minus 9y equals 17. That empty space is going to be filled with 4y minus 3. 7 times 4y gives us 28y. 7 times negative 3 gives us negative 21. Minus 9y equals 17. Combine my like terms, so I get 19y minus 21 equals 17. I combined these two here. Add 21 to both sides. Divide by 19. Oh, not x. Still y. Just so used to writing x. Y equals 2. There's half of our answer. So we're going to take that 2, we're going to plug it in right there, a second substitution. and x is 5.